It's from the Brilliant website.
Okay, okay. So, okay,
Yes, sir.
problem.
So yes, they've given the source as well. It's 1984 Tournament of Towns, problem
Okay,
one.
okay, okay. Uh, Let's try.
Yes, sir. So on an island there are 13 gray,
Okay, 13 gray.
uh, yes, 15 brown,
Okay.
and 17 crimson chameleons.
Hmm.
Yes, sir. So if two chameleons of different colors meet, they both simultaneously change color to the third color.
Okay.
So if gray and brown meet, they both become crimson.
Okay.
Yes. Now, the first question is it possible that they will eventually all be the same color?
Okay.
Yes, sir.
So let's try this part.
So, yes,
Okay. So just give me 1 minute. Let me just think. Maybe you have tried
yes,
it a little bit at least or done.
yes, even I need to think.
Okay. Okay. So have you thought anything about this one?
So I'm thinking mod 3 or something like that. Maybe
Okay.
some invariant like that.
Okay.
One obvious invariant is obviously A plus B plus C is 45,
Right.
but that doesn't help.
Yes. Correct. That doesn't help.
Actually,
Mm-hmm.
uh, it's it's either -1 or +2. Like that's the only change that can happen,
Yes.
right, sir?
Yes.
So like you're always getting 2 mod 3. Like minus 1 is 2 mod 3. 2 is also 2 mod 3.
Okay.
So I I don't know how to put it, but yeah.
I see. Yes. So you're saying that the number is remaining constant 2 mod 3.
Yes. Or no, like a
Model.
minus 1 is congruent to a plus 2 mod 3. So like that.
Yes. So sorry. Yeah. You mean that it is changing mod 3 to it changes by 2 mod 3 always.
Yes, changes by 2 mod 3. Yes, sir.
Right. So you are saying that after n steps, after n steps, we will have, if initially it is a plus b plus c, then it will
Yes,
be
sir.
a plus 2n, b plus 2n, c plus 2n, modulo 3.
Modulo 3. Yeah.
Yeah,
So
this
something like this.
exactly this, right? Yeah, this is
Yes, yes.
exactly correct. Okay.
So now if we have 4500,
Hmm. Hmm.
mm, so that means uh yeah, so 0 is 0 mod 3. Uh
Hmm.
but we're adding 2n, so okay. Or maybe we can notice one more thing, sir.
Hmm.
Not all of these, the three numbers, they're not all 0 mod 3 at the same time. We could say that as well.
Yeah, initially they are not all 0 mod 3 at the same time.
Yeah,
Uh-huh.
and oh, I don't think it's possible that they can all be 0 mod 3 at the same time. So
Okay.
like we can have
So if
15, 16, 14, so something like that. Yeah.
so if that happens, then what is the contradiction?
A 4500, they're all 0 mod 3. The
Right.
end state.
No, but your claim that none of them are so sorry.
Okay.
No, sorry. Your claim is that they all will never become 0 mod 3.
Yeah, I have to prove that. Yeah, I'm
Yes.
thinking so. One
Yeah.
second.
Prove it.
So our initial set that we have, it is 1, 0, 2.
Correct.
Yes. Now we are adding 2n to this mod 3. So
Hmm. Yeah. So it will not become right.
yes, yeah,
Yeah.
yeah.
Because yeah. Otherwise they have to be equal mod 3. Because yeah, right? Because this
Correct. Yes,
this implies that that
it will
a
be distinct. Yeah.
yeah is minus 2n mod 3.
Yes.
But that is not the case. They are not equal mod 3. Right?
Yes. Yeah.
That is it. Yeah.
Okay.
Uh, uh,
Now,
yeah, there's a second part to it.
yes, the second part
Okay.
is
Just 1 second. So the
uh,
small, I mean, it's the same thing. It's the same. It's the 1 second. Yeah, it's the same thing. But maybe initially how I saw it was just that you see the difference of the numbers modulo 3 does not change.
oh,
So the pairwise
right.
difference. Yeah.
Okay.
Like maybe if
Yeah,
you solve this problem
same thing then.
a year ago, you would have said like that.
Oh,
Right, I
yeah,
mean,
that makes
like
sense.
you
Yes.
understand. Yeah, that's
Yeah.
okay.
Yes. Second part is it possible that they'll eventually be the same number of gray, brown, and crimson? Again, same argument. They would all have to be 15, but 15, 15, 15 is 0, 0, 0 mod 3. Not possible.
Right. So Okay, so I'm not writing it. I understood.
Yes, so yeah, neither A nor B.
Right. Okay, so those were the
And it
two.
is the correct one. Yeah, it is the correct one.
Okay. So then not very difficult problem.
Yeah,
But yeah,
yes.
it's nice. It's old, so okay.
Yes, I'll just look up more questions.
Okay.
Yes, so I saw this question on Stack Exchange.
Okay.
So we have an integral I. So it's the integral from 0 to 3
Okay.
of x factorial by x squared plus 1 dx.
X factorial.
Yes, sir. Or yeah, something like that.
Okay.
Or
By
maybe we should say it gamma x minus 1.
right. Okay.
Oh, sorry, gamma x plus 1, right, sir?
I think gamma x plus one. Yeah, with the usual
Yes,
definition. Yeah.
yes.
By
By x squared plus 1.
dx.
Yes, sir. So now we have to show that this is greater than 1 plus root 5 by 2.
Okay. Hmm. So can you remind the definition of gamma x? Do you remember?
Yes, the integral from 0 to infinity of e power, uh, not sure, so 1 second. Minus x, something like that. Yeah, so gamma
E
z.
power or minus x or
e-
t?
Yeah, e power minus t power x minus 1 dt.
Correct.
So so yes.
Okay. And also just to, because I've not done this in many years, can you show this thing? This should be true.
Yeah. Yes,
And
yes. By parts, I think if we can show it.
you can show it by parts. And is there any what should be the restriction on x?
Uh, Restriction on x, no such like it can be x can be complex number, any complex number.
No, no, no.
But
No, x cannot
the
be any.
no, yes, so the real part of x should be greater than 0.
Okay. Yes, yes. So that is at least what I was thinking, right? That the real part should be greater than zero. Okay. So let's just say that everything is real and x is greater than zero. Okay.
Yeah.
Yeah,
Yes,
I
sir.
understand one can do it like that. So, but okay. So this just follows from by parts. All right. So then how
Yeah,
do we
by
show that?
parts.
Okay.
And the integral on the left, it's apparently very close to 1 plus root 5 by 2. So we need a tight bound.
Okay. Okay.
But I don't know how to approach this.
Right. Yeah. This is I'm just writing. So we can try to again exchange the two integrals. We can, but first we have to say that it is valid to exchange the two integrals and then exchange. Otherwise, you don't know how to do. So again, try to
Yeah.
view, right? View this as a function in two variables, and this becomes so the plane from 0 to 3 is x. This is the x, and this is the t. Yeah. And we are integrating on this strip. No, actually, yeah, only in the positive. Okay, now let me just say why you can exchange this. So either you exchange and say that it is finite, or you yeah, you can. So yeah, right. So for I'll suggest that for the time being, you
Yes,
assume
sir.
that you can exchange it. Okay.
Okay.
Maybe in the end I will try to explain why you can exchange it. But because you see, in order to get anything interesting, you have to exchange it, I think. We will look
Okay.
at the solution there if later on needed. You'll see possibly they will also do something, but let's see. So anyways, or like we can even use the values of approximate values of this, but let's try to do it ourselves first, then we can,
Yes, sir.
like, just conceptually if we can do it. So now how do you, yeah, now can you put some lower bound, upper bound, right?
Mm,
So you see, think of it like t is fixed, right? For every fixed t, you are doing this, correct?
yeah.
You fix
T
the
is
t,
constant.
yeah.
Yeah.
So the e to the minus t is
So we're
sort of,
looking,
mhm.
yeah, we're looking at a constant times like a constant to the power x by x squared plus 1. That's
Yes,
what we're looking at.
exactly. And in fact, maybe for more clarity, you can write it. You can write e to the minus t outside.
Yeah. Yes.
So can you put a lower bound on this t to the x? You have to do some approximation because t to the x you cannot integrate, right?
Correct. Yes, sir.
So what will be a lower bound you put? X and t. So t is, yeah, and why not also also you take x t 0 to 1 only, and that's also a lower bound, right?
Right. Yes, sir.
Because
Yeah.
beyond that it becomes small. I don't think it should play a role.
Correct.
So
Correct. Yes, sir. But how do we figure out a lower bound for the inner one? T
yes,
power x by x squared plus 1.
right, right. So t is yeah. So I think it's something like this, right? T to the x is bigger than something. What is that? Bigger than t to the 3.
Yes.
Is this correct?
Uh, and this is because t is between 0 and 1.
Yes, right.
Okay. Yes. Yes.
This is, and this like looks like a sensible thing to do. So
Yes.
to simplify, right. So we have this, and now this is something which you can integrate.
Yeah. That'll just be tan inverse 3 minus tan inverse 0, which is 0.
Okay. So tan inverse 3.
Yes, tan inverse 3.
Correct. Right. And then you
And
can
then
tell some value of this.
e power minus t cube dt. Yep.
Yeah, that you can do. You're getting something like this after a lot of approximations.
Yeah, yes,
Means
sir.
after some oversimplifications, I should say. Yeah. Is this bigger than
Tan
this?
inverse 3 by 4e. Okay, let me check, sir. I have a.
Right. Tan inverse root 3 is already pi by 3. This is more than that. So it's pi by 3. But e is also there. Yeah, I know.
No, sir. It's not bigger.
So how much is
Actually,
it?
the first number is 0.11.
Okay. This one.
Uh, yes, and the second number is 1.6.
Right. So well known. Yeah. Yeah. So then you have to again. I don't know how much. So you just integrate. Maybe if you integrate this honestly, then you will get.
Yeah.
Yeah.
Let me just check what the integral is
Yeah. Just
so
do.
that we can see how good our bound is.
Yes. Yes. Yeah. Just check that. Maybe. Yeah. Maybe it will not work. Seems.
So this integral is actually 6 minus 16e.
6 minus 16e.
Yeah, 16 by e, sorry, 16 by
Ah.
e.
Then it is fine.
Yeah, yeah.
Okay.
And this 16, yeah, this multiplied by tan inverse 3. 1 second, sir.
Yeah.
So this is actually 0.142.
Okay. Okay. So it doesn't work. Right.
Yeah. The first answer that you got, so the 4 by e one,
Mm-hmm.
it's actually pretty close to the integral.
It's pretty close. Right. So yeah. So it doesn't. Doesn't work.
Maybe we could increase the 0 to 1, maybe you could make it 0 to 5 or something. But it won't make
That
much of a
that
difference.
thing. Yeah. So you just yeah. But then you will not be able to make this approximation with t. Right. With the
Oh,
t.
okay. The t cubed. Oh,
Yes.
yeah, yeah.
So something better is needed. Maybe we can look at the solution. This gamma thing I have not worked with this
There is no solution, sir. I mean,
not yet.
there's one, I will just read it out 1 second.
Right. I don't know what are the values of gamma x. Look at- Maybe we could break it, right? 0 to 1 and 1 to 2. And then
Yeah,
use the
0 to 1. Yeah, even I was thinking that.
factorial values, right? 0 to 1.
Gamma 2 will be
No, yeah,
1.
gamma 2. So that will be at least 1. Yeah. Something.
Yes, sir. So one answer they've given
Mhm.
is okay. So they've said that any convex function, and they've given that our integrand is convex on
Okay.
AB, and for any C belonging to AB, we have that
Jensen.
uh yeah, something like that. Yes, sir.
Yeah, yeah, I was thinking that, but that's
For
a little
all
advanced one.
A,
Yeah, yeah. Okay, okay, wait. One
yeah,
second. One second.
yes,
Then
sir.
you have to first yeah. So yes, Jensen's inequality. I was thinking of that in the middle, but let me first see. Hmm. Right. So yeah. So can you share the screen or something? Or
Uh, uh, so
yeah, or you can say
can I
actually.
send you the link? I'll send you the link to the
Yes, that's fine.
yeah, I'll send the link to the answer 1 second.
Right. Yeah, Jensen's inequality is the first inequality. If you look at Rudin's second book, I think it's there.
Real and complex analysis.
Yes. And chapter on know the name. Convexity, the first inequality is
And sir, I ordered monkeys for topology. I think
already.
it will come tomorrow. Yeah.
Okay.
What I'm doing is the CMI book list. I'm ordering like all the books that I can from the book list. There are about 18 books that they've given.
Yes.
Their references.
Mhm.
Actually, they've given 20, 22, but some of them are computer science, which I might not need. So I've just ordered the math books for now.
Right, right. Okay.
So yeah, so everything I need for undergraduate, like my reference, I've got linear algebra, abstract algebra, analysis.
Right.
Which will be taught in Azim Premji.
Uh,
Uh, Complex analysis is a elective which I'm planning on taking. So
uh,
for that, I will use whatever text they give, and for the rest, I will use whatever text they give and the ones that I've ordered. And topology is for self study.
yes. What do you can study? Interesting. Right.
Yes, sir.
So they
And
have.
I'm also following a
Mhm.
yes, I'm also following a playlist on YouTube by NPTEL, which is
Yes.
it's organized by IIT Bombay, I think. So it's free online
Right.
lectures.
Right. Right.
So they have points in topology.
Yes. I mean, why don't you? I mean, actually, I think I forgot. I was going to tell you. Why don't you take that course? Right.
Which one, sir?
Yeah, yeah. So you can. I'll show you. I think I was going to tell you, but then I forgot.
Okay.
You should take because they will make you write the exams also. So it will be very good.
Okay, okay.
It's I think it starts at the end of July or something. Okay.
Oh,
So yeah. So
okay.
obviously you should not overtake many courses, but
Yes.
yeah, you can take one of these. You can take that.
And sir, Professor Joydeep, that the one that you just scrolled by, I think he's a lecturer at Azim Premji.
Okay, where? Which one? Oh, Joydev Datta.
Calculus of unreal. Yeah, yeah. Yes.
Okay, okay, right, okay.
And I think he teaches analysis. If I'm not sure. Let me just.
Mhm. Yeah. Right. But let me see. Wait. So you should take some good course, which is little challenging. That will be good.
Yes.
Yeah, you can actually take this measure theory course. I think.
Measure theory.
Yeah, you can think of
Yes.
taking this one. Or actually measure and integration. Case one is obviously good. Good question.
And it starts. When does
All,
it start, sir? The
all
measure and
start.
integration.
I think they all start at the end of July, towards the end of July.
Yeah, 24/7. Yes, yes.
Yes,
So
yes,
I think they've lined it up with the college, like when colleges
yes,
tend to start in
yeah.
like
But
August.
right, but it will end a little earlier only. So
Yeah,
yeah,
most of these are, I guess,
yes,
three
and
months,
you can
four
also look
months.
at this fuzzy set theory. Something which you won't get in your college. It's good to learn new things. Yeah, these are good.
Right.
Uh, yeah, this is quite a unique course, geometry of vision. It's a very unique course.
Oh,
Like this course, I had taken this
but
course.
actually written a
Huh?
project on I think on similar things. So in 11th grade we had some physics project, and I used I did geometry of vision and apparent height and length. It changes by tan inverse theta and all those I did. I don't
Mhm.
remember exactly, but
Right. Yes,
I
yes, that is okay.
I
That
had done.
yes, but this will be. You should check it out. Then you will know. Yeah, it's quite interesting. Yeah. The name is
Yes,
similar, but yeah, the top you see, check it out, then you would know. And yeah, and
yes.
because the professor is amazing, actually, this person, Vijay Ravi Kumar, as a teacher. Yeah,
Oh,
he was at
okay, okay.
CMI, so I know him. And
Right.
yeah, point set topology actually is something which you can just study on your own also. Means that you don't need to take the course. But yeah, anyways, it's up to you. But the geometry of vision, I will
Yeah.
highly recommend that you should look at.
And are these free, sir? I think they're free, right?
Yes, yes, yes. Means for the exam they will charge something, but you should,
Okay, okay.
if you take it, you should write the exam. Okay, that's the important
Yes,
thing.
yes, sir.
And don't take
Right.
more than two. Okay, don't take more than two. Take one or two and do
Right.
it properly. That's important
Yes, sir.
because then only it
So
will
are
add.
there any combinatorics? Because that's sort of my weakest area.
Yes, you see, combinatorics is there. Yeah, this professor is also very good actually, Narayanan. Okay,
Okay.
I know him.
Right,
He was
right.
there in this workshop actually, Pondicherry.
Oh,
Yeah,
okay,
so
okay.
he's. But you can take it. But yeah, if you ask me, you should take geometry of vision and something else, maybe fuzzy set theory or something. Okay, yeah, because
Right.
combinatorics will be a straightforward thing. What is already well documented and or measure theory you should take. Okay, because
Right.
these things take a long time to settle. Okay, and they provide new way. That combinatorics course will not teach you, tricky things. It will just develop some straightforward theory. Okay,
Okay.
very
Okay.
straight,
Okay.
very something which you can just passively also do. But these measure theory and so on, they take some time to get into your system, means so that you start thinking in those
Yeah.
terms.
And I guess they're more relevant for my college course as well.
Yes, yeah, but but combinatorics is easier to learn, right? It's an easy way. I mean, you will have some course in discrete maths in your college, right? Those things will be there. So
Yes, sir, there
you
is
will,
one.
yeah. So
There
you
is.
can take them and learn combinatorics. But measure theory is not easy to learn. Yeah, it is not. Everybody doesn't end up learning measure theory. Okay, most people by that time they leave maths, right? It comes
Okay.
measure theory is supposed to be taught in masters, MSc. Okay, but it's one of the subjects
Right, right.
which you can say from basic terms. You should not worry about. And geometry of vision is also
Sir,
unique.
and
Yeah.
what website is this? I'm not able to find
Yes, if
it.
you I just googled
Swayam
NPTEL.
M.
Yes, NPTEL Swayam, and then go to course catalog. Yeah. I will suggest you take the measure theory course and
Okay,
generalization.
got it.
Those two. Okay. Yeah. Commentaries
Okay,
and all
okay.
are there, but they are
So
mostly for
measure theory and geometry.
yeah, because other courses they're mostly for students who are like in some colleges where not much is taught. Okay. But you already are doing
Okay.
prepare for ISICM entrance, so you know enough combinatorics to learn it when you need it.
Yes.
Okay. So let's continue with this. Yeah. So it's just 1 minute is left. So let's take a break and then we will try to
Okay,
understand.
yes, sir.
Looks like quite a
Yes, sir.
long thing, but yeah, anyways, we'll do it.
Yeah, it's a
Bit
big
long.
one, yeah.
So 5 minutes, then we'll meet.
Okay, yes, sir.